Hello, welcome to our channel for probability and statistics. In this video, we will talk about how to estimate the confidence interval of the difference between two proportions. So if you want to estimate the difference between two populations' proportions, so for example, here P1 might be the proportion of smokers with lung cancer, and P2 is the proportion of non-smokers with lung cancers. And we are interested in estimating the difference between these two proportions in medicine science. So first, we will select independent random samples of size N1 and N2 from these two binomial populations with means N1P1 and N2P2, and the variance N1P1Q1 and N2P2Q2. Then we can determine the number X1 and X2 of people in each sample with lung cancer, and form the sample proportions P1 hat equals X1 divided by N1 and P2 hat equals X2 divided by N2. So, a point estimate of the difference between these two proportions P1 and P2 is given by the statistic P1 hat minus P2 hat. And we know in large samples, the P1 hat and the P2 hat both have approximately normally distribution. So with means P1 and P2 and the variance P1, P2, N1 divided by N1 and P2, Q2 divided by N2. So we call this term P1 hat minus P2 hat is sampling distribution of the P1 and P2, with mean equals the population difference of these two populations, and variance of this P1 hat minus P2 hat equals P1 Q1 divided by N1 plus P2 Q2 divided by N2, because this plus of variance depends on the assumption that these two samples are independently selected from two populations. So therefore, we can go one step further that this say, which is standardization of P1 hat minus P2 hat, has standard normal distribution. So the probability of Z between minus Z half alpha and Z half alpha equals 1 minus alpha. So alpha is the significance level and 1 minus alpha is confidence level. So after mathematical manipulation, we can get the confidence interval for the population P1 minus P2 is between this lower bound and this upper bound. So lower bound and upper bound both come from the sample information, with the point estimate P1 hat minus P2 hat minus Z half alpha times the square root of the sample variance, and upper bound is P1 hat minus P2 hat plus Z half alpha times square root of sample variance. And the Z half alpha here is the Z value, which leaves an area of half alpha to the right in standard normal density curve. So next we will take a look at an example of using this formula. So certain change in a process for manufacturing component parts is being considered, and samples are taken under both the existing and the new process, so as to determine if the new process results in an improvement. If 75 of 1,500 items from the existing process are found to be defective, and 80 of 2,000 items from the new process are found to be defective, find a 90% confidence interval for the true difference in proportion of defectives between the existing and the new process. So the solution is, if we let P1 and P2 be the true proportions of defectives for the existing and new process, then P1 hat and P2 hat can be found from the sample information. So we get P1 hat about 0.05 and P2 hat is 0.04. So the point estimate of P1 and minus P2 is 0.01. So we use the table for the normal distribution, can find say equals 0.05 equals 1.645, because we want to get 90% confidence interval. So here alpha is 0.1, so half alpha is 0.05. So therefore, we can substituting this information in the formula. We can get, say, half alpha times the square root of sample variance equals 0.0117. So the 90% confidence interval for the population proportion difference is between minus 0.0017 and 0.0217. Since this interval contains the value 0, so there is no reason to believe that the new process produces a significant decrease in the proportion of defectives over the existing method. And one thing you have to note is that the prerequisite that we can use this formula is based on the large sample. So which means N1 P1 hat and N1 Q1 hat and N2 P2 hat and N2 Q2 hat both will be greater than or equal to 5 before we can use this formula. So Q1, Q2, which equals 1 minus P1 and 1 minus P2 here. Thanks for watching and subscribing our channel.